Hey, what's up, guys? This is Sheng here again. So this time, 1799. Maximize score after n operations. So we're given like numbers, an array of positive integers of size of 2 times n, right? And you need to perform n operations on its array. So in the ith operations, you choose two elements and you receive the score by the step of the operations times the GCD, the greatest common divisor of those two numbers, and then you remove the xy from the numbers, which means that whenever you have chosen two numbers, you cannot use them anymore. Right? You need to return the maximum score you can receive after performing n operations. Right? So for example, we have 1, 2 here. Obviously, there's only one option here. You just choose those two numbers where you get 1. So for example, in example 2 here, right, you have a bunch of options, but the optimal solution is that we do a GCD of 3 and 6, which is 3, plus 2 times GCD of 4 and 8, which is 11, right? And so the constraint is like n is equal to 7, right? And then the range of the i's is about 10 to the power of 6, right? So, I mean, this one, I think it's kind of obvious that this one is like a DP problem, right? Where and since the n is small enough, we can simply like brute force to choose all the combinations, the possible combinations of x and y, right? And the only thing we have to be careful is that we have to use like a DP state, basically, which means that the DP state is like this. So we have going to be a step, right? So we have a step, and then we have a mask, right? Every time when I say this kind of n, it's like within 10. I would always try to use mask. So which means that this DP means that at the current step and with the mask, which means it can tell us like which number have been used before and which numbers we can use, right? And which number we haven't used before. So here I use 0 and 1. So 0 means that not used, right? And 1 means used. Okay. And the length of this mask is like it's basically 2 to the power of 14th, right? Yeah, 2 to the power of 14th. So which is it's acceptable, right? And here, at each of the step, basically, oh, sorry. So for the DP step mask, it means that at this step and with this kind of remaining numbers we can use, what's going to be the maximum score we can get, right? And then so the initial state will be DP step 1 and the mask is 0, right? And we stop when we have like the mask equals to 01, right? Then we know that's the time we have checked all the GCD, right? And then inside each of the DP here, we simply loop through this mask, right? We try all the possible combinations of the two unused numbers, and then we just use those two, right? Yeah, so I think the DP state is pretty straightforward, right? And let's just start coding then. I mean, so first we have n equals to length of numbers, right? That's the total numbers we're getting here. And then we have a defined DP, right? So we have step, right? And then we have a mask. Then I'm gonna use this one for the cache, for the memorization, right? Top-down memorization. So like I said, if the mask is equal to this n minus 1, right? And then we return 0, right? Because this is a little bit bit operation manipulation, right? So this one means that they're all 1, right? Whenever the mask is all 1, then I return 0. Otherwise, the answer is 0, right? starting from 0, and then I need to find those two numbers. So I simply loop through the numbers from I here. So I check if the mask is 0. So which means that if this one and this one is equal to 0, right? Then I know, okay, so this i's number is my first number, right? And then I need to find the second number. So to find the second number, we can simply start from this I here, right? I plus 1 dot n here. Because this one will make sure we're not picking the same number twice. And since we're going to loop through the i's regardless, we can simply do the j here, right? Starting from I. And then from here, we also need to check if the j's number is available, right? Right. So then we know, okay, so we have found two available numbers we can use, and that updates the answer. So we have the answer gonna be, so first is a step, right, times the GCD, right? GCD of nums of I dot numbers, right? Okay, and the remaining is plus the DP, right? The updated mask, which is the first is step plus 1, and then the mask we need to toggle 2 bits, right, from 0 to 1. So the first one is the I, right, and then the second one is the it's J, right, because we need to mark those two numbers, right, and then in the end I just return the answer, right. So I think Python has like a built-in GCD functions here, but if there's no built-in GCD functions, you can always write your own, right? So it's kind of uh, straightforward, to write your own GCD. GCD, I think we have A and B, right? So basically while B, right, and then we have A B equals to B dot A mod B, right? And then I return A. That's basically the a simple implementation of the GCD, right? Cool. So and here I just simply return the DP, right, from at step 1, and at the beginning every bit is 0. Okay, run none type. Yeah, return answer. Okay, cool. Submit. Yeah, so it passed, right? I mean, so for this one, the time complexity, I mean, for this one, I would make assume this is O of 1 maybe. And then here, for the DP here, we have a step, right? So step is n, right? Times the mask, right? The mask is 2 to the power of n, basically, right? And inside of each, this is the total the total state number, and each of in the state numbers we have. So here we have this one. So what's this? This is like times n square, right? Yeah. Basically, it's in total, it's gonna n cube times 2 to the power of n. Yeah, I think that's the total time complexity. And the space complexity is the number of the states, right? Which is the of n times 2 to the power of n, right? That's how you calculate this top-down DP complexity. Yeah, so this one, I think that's pretty much it is, right? I mean, it's a pretty straightforward, like top-down DP problem, Thanks to the small constraints, we can simply brute force all the possible combinations of those two unused numbers, right? And then we just use a bit mask to represent that state, each state, and in the end we simply get the maximum out of all the combinations, right? Cool. I think that's it for this problem, and thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.